We have the Fibonacci sequence A sub n is defined as 1, 1, 2, 3, 5, 8, 13, etc. And we can write this as a recursive relation. So we'll say the n plus second term is the sum of the n plus first with the nth term. And this is for values n greater than or equal to 1. We know that this sequence diverges, it goes to infinity, but we want to look at the ratio of the terms. So for example, if we look at the ratio, we'll define it as b sub n. That's going to be the ratio of the nth plus first term with the nth term. And so just to look at a couple of these, this will be like second term divided by the first term, third term divided by the second, etc. So we're just looking at this ratio. We want to see what limit this goes to. So we're going to assume that the limit exists. Okay, we're going to assume the limit is actually b. Okay, so now let's start the problem. Okay, we know that the n plus second term is the n plus first term plus the nth term. From here, we're going to divide both sides by the n plus first term. So now we have the n plus second term divided by the n plus first term. And then these are going to cancel. We have 1 and then plus a sub n over a sub n plus 1. Now, recall that b sub n was the n plus first term over the nth term. So this right here is the reciprocal of this. So this is really 1 over b sub n. And then the n plus second term over the n plus first term, that's going to be b sub n plus 1. So rerunning this, this will be b sub n plus 1 is equal to 1 plus 1 over b sub n. Now recall that we said the limit as n approaches infinity of b sub n is equal to b. So whether n here is n plus 1, n plus 2, whatever, the limit is still going to be b. So this is b, and this is also b. Okay. So I guess you can say, okay, intermediate step, let's take the limit of this until we get this. I mean, if these two sides are equal, then the limits have to be equal. That's basically what we're saying. Now we just use algebra, so we're going to multiply both sides by b. We have b squared is equal to b plus 1, and then we're going to bring everything to the left here. We have b squared minus b minus 1 is equal to 0. Quadratic formula says b is equal to, okay, opposite of the second term. So the second term is negative 1. Opposite of that is 1. Plus or minus the second term squared, that's also 1. Minus 4 times the first term times the last term. That's going to be all over 2 times the first term. So we know that it's 1 plus or minus. Let's see. Negative 4 times 1 times negative 1 is positive 4. Plus 1 is 5. And then that's going to be all over 2. Now we have two answers here. We have a positive and a negative. Recall that b sub n was a ratio, and this is the ratio of all positive numbers because the Fibonacci sequence is all positive numbers. So b, the limit, also has to be positive. So b is going to be 1 plus square root of 5 over 2. And this is our limit. Now, we can also rewrite this as phi, and this is known as the golden ratio.